And now, in this lecture, we'll find out the radius of a circle. In the drawing, we have a circle. Inside this circle, we have chord dB. Chord dB equals to 2 units in its length. We also have here chord AC. Is equals to the square root of 2 units in its length. This is angle DEB. Angle DEB equals to 45 degrees in size, and our mission is to find out the radius of this circle. So first of all, we join points D and A together by straight line. By joining points D and A, we consider peripheral angle DAB. This is peripheral angle DAB, and peripheral angle DAB is equals to peripheral angle DEB is subtended on chord DB. Again, this is peripheral angle DAB. And peripheral angle DAB is subtended on chord DB. We define the size of this peripheral angle DAB as x over 2. Repeat again, peripheral angle DAB that is subtended on chord DB is equals to x over 2 degrees according to our definition. In the next step, we will define the center of this circle, this point, as point O. And we will join points O and D together by a straight line. Likewise, we join points O and B together by a straight line. By doing this construction, we can derive central angle DOB. This is central angle DOB, and this central angle DOB is subtended on chord DB. So, those two angles, they are both subtended on the same chord called DB. So now we can implement rule 13. So I repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and this is peripheral angle ACB. Peripheral angle ACB, the size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Likewise, we also have here central angle AOB. This is central angle AOB. It is subtended on the same chord called AB. And according to this rule 13, the size of the central angle AOB is twice as large as the size of this peripheral angle ACB that is subtended on the same chord called AB. We know that the size of this peripheral angle ACB is theta, and therefore the size of this central angle AOB must be equal to 2 theta. Okay, so the central angle is twice as large as the peripheral angle that is subtended on the same chord. So we can implement this rule 13 in our drawing. Why? Because in our drawing we have peripheral angle DAB that is subtended on chord DB, and this is central angle DOB that is subtended on the same chord called DB. So those two angles are both subtended on the same chord called DB, and therefore the size of this certain angle DOB must be twice as large as the size of this peripheral angle DAB. The size of this peripheral angle DAB is x over 2. Therefore, the size of this certain angle DOB must be equal to x. Okay? According to rule 13, of course. So the size of this certain angle DOB is x because it is twice as large as the size of this peripheral angle DAB, that is x over 2. Okay. In the next step, we define the size of this angle. This is actually peripheral angle ADC, peripheral angle ADC. We define the size of this peripheral angle ADC as y over 2. In the next step, we join points O and C together by a straight line. Likewise, we join points O and A together by a straight line. Actually, by doing this construction, you can adhere central angle COA. This is central angle COA, and this central angle COA is subtended on chord AC, exactly like this peripheral angle CDA, that is also subtended on the same chord CA. So those two angles, they are both subtended on the same chord CA, and therefore the size of this central angle must be twice as large as the size of this peripheral angle CDA. And the size of this peripheral angle CDA is y over 2, and therefore the size of this peripheral angle COA must be equal to y over 2 times 2, that is y. Okay. In the next step, I'll copy this green triangle EDA in a new page, and we'll implement rule 4 on this triangle EDA. So actually, this is triangle EDA that I copied from the original drawing. This is angle EDA. The size of this angle EDA is y over 2 degrees. The size of this angle EAD is x over 2 degrees. And this is angle BED. The size of this angle BED is 45 degrees. So those two angles, they are both defined as interior angles because they are located inside triangle DEA. So I write it down. Those two angles, they are both defined as the interior angles of this triangle EDA. are the interior angles of this triangle, triangle EDA. While this is angle DEB, that is located outside triangle DEA, and therefore it is defined as an exterior angle in relation to this triangle EDA because it is located outside triangle EDA. So I'll write it down. This is an exterior angle of this triangle, triangle EDA. And this angle, angle DEA, is also defined as interior angle of triangle DEA because it is located inside triangle DEA. So we have here three interior angles, 1, 2, 3, and one exterior angle, angle DEB, that is an exterior angle in relation to this, or it is an exterior angle of this triangle, triangle DEA. So in the next step I present to you rule 4, and we will implement rule 4 in this triangle, triangle DEA. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles, A, B, and C, and all of those three angles are defined as an interior angles of this triangle, because they are located inside triangle, this triangle. While this is angle E, that is located outside this triangle, and therefore this angle, angle E, is defined as an exterior angle of this triangle, According to this rule 4, the size of this exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C, that is an interior angle that is definitely adjacent to this angle, angle E. The other two interior angles that are not adjacent to this angle E are those two angles, A and B. And the sum of those two angles is of course A plus B. According to this rule 4, the size of this angle, the exterior angle, angle E, it is equal to the sum of the two interior angles that are not adjacent to it. That is to say, angle E equals to A plus B. Again, the size of angle E is A plus B, because A plus B, those two angles A and B, there are two interior angles that are not adjacent to it, and the sum of those two interior angles, that is A plus B, is the size of this exterior angle, angle E. Okay, so according to this rule 4, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. In this case, this is the exterior angle, angle E, and the size of this exterior angle E is equal to A plus B, because A and B, there are two interior angles that are not adjacent to this angle E. So conclusion, we found out that the size of angle E is A plus B. Okay, so we can actually implement rule 4 in our drawing. Why? Because in our drawing we have triangle DEA, and those two angles, x over 2 and y over 2, there are two interior angles. And this is angle BED, that is defined as an exterior angle of this triangle DEA because it is located outside triangle DEA. And according to rule 4, the size of the interior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle BED. This angle BED is definitely adjacent to this angle BED. And the two other interior angles that are not adjacent to it are those two angles, x over 2 and y over 2. So according to rule 4, the size of this exterior angle BED is equal to x plus 2 plus y plus 2. So I write it down. So according to rule 4, the size of the exterior angle, angle BED is equals to x over 2 plus y over 2. I'll repeat again why, because those two angles, x over 2 and y over 2, they are both interior angles that are not adjacent to this angle BED. And therefore, and the sum of those two angles is of course x over 2 plus y over 2. And this is the size of this external angle, angle BED, according to rule 4. But it is given us a question that the external angle BED is 45. So we can substitute this angle BED by 45. We do it now and get that 45 equals to x over 2 plus y over 2. So here we will multiply this equation by 2, and finally we get that 45 degrees times 2 is 90 degrees, and 90 degrees equals to x over 2 times 2, that is x, plus y over 2 times 2, that is y. So in total, x plus y equals to 90 degrees. We subtract x from this equation, and finally we get that y equals to 90 degrees minus x. Okay. Y equals to 90 degrees minus x. In the next step, I'll present to you the law of cosines. Actually, we'll repeat again quickly on the law of cosines, and I will implement the law of cosines in this triangle BOD. Okay, so I'll repeat quickly on the law of cosines. According to the law of cosines, first of all, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. This triangle ABC, the following equation is true. First of all, the length of side AB is A, side AC equals to B units in its length, and this is side BC, that is equals to C units in its length. According to the law of cosines, in this triangle ABC, the following equation is true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta in this triangle ABC is equals to A squared plus B squared minus C squared over 2 times A times B. So, in the next step, I will copy this triangle BOD in a new page, and we will implement the law of cosines in this triangle BOD. Side BD equals to 2 units in its length. What is the length of side OD? Point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of this circle. That is the radius that we are looking for. So we'll define the radius of this circle as R, therefore OD equals to R. Likewise, what is the definition of line segment OB? Line segment OB is also the radius of this circle, that is the radius that we are looking for, and therefore line segment OB is equals to R. It is the radius of the circle. So actually, this is triangle BOD. And again, this is triangle BOD that I copied from the original drawing. We found out that BO equals to R, and DO also equals to R, and this is angle DOB, this equals to X. Now we will implement the law of cosines in this triangle, triangle BOD. So according to the law of cosines in this triangle, triangle BOD, cosine X, this will be equation 1, cosine X equals to OB square, OB is R, therefore OB square is R square, plus OD square, OD is R, therefore OD square is R square, so it is plus R square, minus BD square, BD is 2, therefore BD square is 2 squared, that is 4, so it is minus 4 over 2 times BO, BO is R, so we substitute BO by R, so it is 2 times R, times OD. OD is also R, so we substitute OD by R. So in conclusion, we should find out that according to equation 1, cosine X equals to R squared plus R squared minus 4 over 2 times R times R. R squared plus R squared is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 4 divided by 2 times R, that is 2R squared. So here we have 2R squared over 2R squared is 1. Remember, so here minus 4 over 2R squared. So cosine X according to equation 1 equals to 1, and here we have we divide both the numerator and the denominator of this expression by 2. And you get that minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in conclusion, we should find out that according to equation 1, cosine X equals to 1 minus 2R squared. In the next step, I'll copy triangle COA in a new page, and we will implement the law of cosines in this triangle, triangle COA. Side CA equals to the square root of 2 units in its length, according to what is given as the question. Side AO, what is the definition of side AO? Side AO is also the radius of this circle that equals to R. Likewise, side OC is also the radius of this circle that equals to R. So actually, this is triangle COA that I copied from the original drawing. In the next step, we will implement the Pythagoras theorem, we will implement the law of cosines in this triangle, triangle COA. So according to the law of cosines, in this triangle COA. This will be equation 2. Cosine y equals to OC squared. OC is R, therefore OC squared is R squared plus OA squared. OA is also R, therefore OA squared is R squared minus CA squared. CA is square root of 2, therefore CA squared is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times OC, that is R, times OA, that is also R. So according to equation 2, we actually found out that cosine y equals to R squared plus R squared minus 2 over 2 times R times R. R squared plus R squared is 2R squared minus 2 divided by 2R squared. 2R squared over 2R squared is 1. And we have also minus 2 over 2R squared. Here we will divide both the numerator and the denominator of this expression by 2, and we get that minus 2 over 2 is minus 1, and 2R squared over 2 is R squared. So in conclusion, we should found out that according to equation 2, cosine y is equals to 1 minus 1 over R squared. Repeat again. We actually found out that according to equation 2, cosine y equals to 1 minus 1 over R squared. But we have already found out that y equals to 90 degrees minus x. So I write it down. We already found out that y equals to 90 degrees minus x. So in the next step, we substitute y in this equation 2, by 90 degrees minus x. So we do it now, and we get that cosine y, and y is 90 degrees minus x, is equals to 1 minus 1 over R squared. And again, according to equation 2, we actually found out that cosine 90 degrees minus x equals to 1 minus 1 over R squared. We have the trigonometric identity that states that sinus x is equals to cosine 90 degrees minus x. According to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation 2, by sinus x. Okay, so we'll do it now, and we get that again cosine 90 degrees minus x is sinus x, and it is equals to 1 minus 1 over R squared. So, we found out that according to equation 2, sinus x equals to 1 minus 1 over R squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. Okay, so we have the expression for sinus x in terms of r, and we have also the expression of cosine x in terms of r. R is the radius of this circle, that is the radius that we are looking for in this question. Now we use the trigonometric identity that states that sinus square x plus cosine square x is equals to 1. According to this trigonometric identity, we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, and we can substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. We do it now, and we get, this will be equation 3, sinus x. We have a sinus square x. So we substitute sinus x by 1 minus 1 over r squared. So the sinus x is 1 minus 1 over r squared. And therefore sinus square x will be equal to 1 minus 1 over r squared squared. And we have also here cosine square x. According to this equation 1, cosine x equals to 1 minus 2 over r squared. And if cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 over r squared squared. And it is equals to 1. Okay, so actually this equation 3, in equation 3 we substituted sinus x in this trigonometric identity by 1 minus 1 over r squared. We substituted cosine x in this trigonometric identity by 1 minus 2 over r squared. And actually found out that sinus square x plus cosine square x is equals to 1. It will be equal to 1 minus 1 over r squared squared plus 1 minus 2 over r squared squared, and this equals to 1. We just substitute sinus x by 1 minus 1 over r squared, and cosine x by 1 minus 2 over r squared, and found out actually that 1 minus 1 over r squared squared plus 1 minus 2 over r squared squared equals to 1. In the next step, we will define, we'll substitute 1 over r squared by t. So according to our definition, t equals to 1 over r squared. So in the next step, we'll substitute 1 over r squared in this equation 3 by t. We do it now, and we get that according to equation 3, we have here 1 minus 1 over r squared, and 1 over r squared is t, therefore we'll substitute 1 over r squared in this equation 3 by t. So this expression in total will be equal to 1 minus t squared, and we have also plus 1 minus t over r squared. We'll multiply this equation by 1. Actually, it is allowable to multiply anything by 1, because by multiplying any expression by 1, you don't change the value of the expression. So here we have 1 and minus 2 times 1 over r squared, and 1 over r squared is t, so we substitute 1 over r squared by t. So in total, this expression will be equal to 1 minus 2t squared, and is equals to 1. So after we substitute t by 1 over r squared, this expression, or equation 3, will be equal to 1 minus t squared plus 1 minus 2t squared equals to 1. So here we'll open the brackets on this side of this equation, equation 3, and we get that according to this equation, equation 3, 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2 times t, and we also 1 minus 2t squared. 1 minus 2t squared is equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t, that equals to 1. So here we have 1 on both sides of this equation 3, so 1 can get cancelled. After we cancelled 1, in this side of the equation 3 we have t squared plus 4t squared is 5t squared, and we have also minus 2t minus 4t is minus 6t, and we have plus 1 equals to 0. So according to equation 3, we actually found out that 5t squared minus 6t plus 1 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Another specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. The only thing that is left to do is to put the data of our specific quadratic equation, that is to say this data inside this general formula for x, and in this way we will find out the value of the values of t, because x equals to t. So we do it now, and we get that we have x equals to t, so we substitute x by t in this equation, and we get that t equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6. And we have also plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36. And we have also minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. a is 5, therefore 2 times a is 2 times 5, that is 10. So in conclusion, we should find out that t equals to 6 plus minus square root of 36 minus 20 over 10. So t equals to 6 plus minus 36 minus 20 is 16, so inside the root we left only with 16 divided by 10. So t equals to 6 plus minus the square root of 16 is 4 divided by 10. So here we will have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10 and 10 over 10 is 1. So if we found out that according to the first solution for t equals to 1. This is from one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we substitute t in this equation by 1 over r squared, and we will get that 1 over r squared equals to 1. Here we will multiply this equation by r squared, and we get that r squared equals to 1. Here we take a root out of this equation, and finally we get that the radius r that we are looking for, the radius r of the circle, is equals to the square root of 1, that is 1. So according to the first solution for t, the radius r of this circle is equal to 1 unit in its length. But actually, it is impossible that the radius r of this circle is equal to r. Why? Because we know that it is given us the equation that chord dB equals to 2 units in its length. Chord dB equals to 2 units in its length, and this chord dB is definitely not the diameter of this circle. Again, this chord dB is definitely not the diameter of the circle. So I write it down. dB is not the diameter of the circle. But we note that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And the diameter of this circle is 2r. So the diameter 2r must be greater than or longer than chord dB that is not the diameter of the circle. Again, because of the fact that dB is not the diameter of the circle, the diameter 2r must be greater than dB, and dB equals to 2. And from this equation, we will derive, we have 2r is greater than dB is equals to 2. So from this equation, we will derive that 2r is greater than 2. 2r is greater than 2. Here we'll divide this inequality by 2, and finally we get that r is greater than 1. So if we found out that the radius of this circle r is greater than 1, if the radius of this circle is greater than 1, the radius of the circle cannot be equal to 1. So this solution is incorrect solution. We cancel this solution, and we will take into account only the second solution for t. So the first solution for t, that t equals to 1, will lead us to a contradiction, and therefore we'll take into account only the second solution for t. And the second solution for t, here we have t equals to 6 plus minus 4 over 10. The first solution for t is t equals to 6 plus 4 over 10, and the second solution for t will be t equals to 6 minus 4 over 10. So I write it down. The second solution for t is that t equals to 6 minus 4 over 10. So t equals to 6 minus 4 is 2, and 2 over 10 is 1/5. So if we found out that according to the second solution for t equals to 1/5 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We'll do it now, and we get that 1 over r squared equals to 1/5. We'll cross multiply this equation, and we get that r squared equals to 5. Here we'll take a root out of this equation, and finally we get that the radius of the circle, that is the radius of, that we are looking for, r equals to the square root of 5 units in its length. Or in terms of numbers, it is equals to 2.236 units. So we found out that the radius r of this circle is equals to either square root of 5 units in its length, or in terms of numbers, this equals to 2.236 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle. We know that chord DB equals to 2 units in its length. Chord AC equals to the square root of 2 units in its length. This is the angle DEB. The size of this angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we join points A and D together by a straight line. By joining points A and D, we created peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle DAB as x over 2. And this peripheral angle DAB is subtended on chord DB. Again, this peripheral angle DAB is subtended on chord DB. In the next step, we define the center of this circle. That is to say, this point as point O. And then we join points O and B together by a straight line. Likewise, we join also points O and D together by a straight line. When doing this construction, we get the center angle DOB. This is center angle DOB. The size of, and this center angle DOB is subtended on the same chord called DB, exactly like this peripheral angle DAB that is also subtended on the same chord called DB. So we found out that those two angles, they are both subtended on the same chord called DB. This is peripheral angle DAB. The size of this peripheral angle DAB is x over 2. While this is center angle DOB, we don't know what is the size of this center angle DOB. So in order to find out what is the size of this center angle DOB, we actually implemented rule 13 in our drawing. So I'll repeat quickly on rule 13. According to rule 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have, this is peripheral angle ACB. Peripheral angle ACB, the size of peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. And we also have here, this is certain angle AOB, and center angle AOB subtended on the same chord called AB. So those two angles, they are both subtended on the same chord called AB. And therefore, according to this rule 13, the size of the center angle AOB must be twice as large as the size of this peripheral angle ACB. So the size of this peripheral angle ACB is theta, and therefore the size of this center angle must be equal to 2 theta. Okay, so the size of a center angle is twice as large as the size of the peripheral angle that is subtended on the same chord. So we can actually implement rule 13 in our drawing. Why? Because in our drawing, those two angles, they are both subtended on the same chord called DB. The size of peripheral angle DAB is x over 2, and therefore the size of the center angle DOB that is subtended on the same chord called DB must be equal to 2 times x over 2, that is x, according to rule 13. So I actually found out that the size of center angle DOB equals to x. Okay? In the next step, we defined the size of this peripheral angle AOC is y over 2. Again, the size of this peripheral angle AOC is equal to y over 2 according to our definition. And this center angle, peripheral angle AOC is subtended on chord AC. In the next step, we join points O and C together by straight line, and we join points O and A together by straight line. By doing this construction, we get the center angle AOC. Again, center angle AOC is created by doing those two constructions. And this center angle AOC is subtended on the same chord called AC, exactly like this peripheral angle ADC that is also subtended on the same chord called AC. So those two angles, they are both subtended on the same chord called AC. And therefore, according to rule 13, the size of this center angle must be twice as large as the size of this peripheral angle. So the size of this peripheral angle DC is y over 2, and therefore the size of this center angle must be equal to 2 times y over 2, that is y, according to rule 13. Okay? In the next step, I copied triangle DEA in a new page, and then we actually implemented rule 4 in this green triangle, triangle DEA. So actually, this is triangle DEA that I got from the original drawing. This angle equals to y over 2, this angle equals to x over 2. Those two angles, they are both defined as the interior angles of this triangle, triangle DEA, because they are located inside triangle DEA. While this angle BED is defined as an exterior angle because it is located outside triangle DEA. So angle BED is an exterior angle, and those two angles y over 2 and x over 2, they are both defined as the interior angles of this triangle, triangle DEA. And it is given as the equation that the exterior angle BED is equal to 45 degrees in its size. Okay? In the next step, I actually presented to you rule 4, and we implemented rule 4 in this triangle, triangle EDA. So I'll repeat quickly on rule 4. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing, we have this triangle. Those two angles A, B, and C are all defined as interior angles of this triangle because they are located inside the triangle, while this is angle E that is defined as an exterior angle because it is located outside the triangle. And according to this rule 4, the size of the exterior angle E must be equal to the sum of the two angles that are not adjacent to it. This is angle C, that is definitely adjacent to angle E. And the two other angles that are not adjacent to angle E are A and B. Those are the two angles that are not adjacent to angle E. And the sum of those two angles is A plus B. So the size of this external angle E, again, the size of this external angle E equals to A plus B. That is the sum of the two internal angles that are not adjacent to angle E. Again, the size of the external angle E equals to A plus B. That is the sum of the two internal angles that are not adjacent to this angle E. So E equals to A plus B. So we can implement rule 4 in our drawing. Why? Because in our drawing we have this is triangle BEA, and this is the external angle BED. And according to rule 4, the size of the external angle BED will be equal to the sum of the two internal angles that are not adjacent to it. This angle is adjacent to angle BED, and those two internal angles are not adjacent to angle BED. And the sum of those two angles is x over 2 plus y over 2. So in conclusion, we found out that the size of the external angle BED is equals to x over 2 plus y over 2. Again, according to rule 4, the size of the external angle BED is equals to x over 2 plus y over 2. That is the sum of the two internal angles that are not adjacent to it. Okay? But it is given as the question that angle BED equals to 45. So we can substitute angle BED by 45. So we did it and found out actually that 45 equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x and y over 2 times 2 is y. So in conclusion we found out that 90 degrees equals to x plus y. Here we subtracted x from this equation and finally found out that y equals to 90 degrees minus x. Again, y equals to 90 degrees minus x. Okay. So, in the next step, I presented to you the law of cosines and implemented the law of cosines in our drawing. So, I'll get quickly on the law of cosines. First of all, the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. This triangle ABC, side AB equals to A units in its length, side BC equals to C units in its length, and side AC equals to B units in its length. And this is angle BAC. The size of this angle BAC is theta. So in this triangle that could be any triangle, the following equation will be true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, in this triangle ABC that could be any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in the next step, actually copied triangle OBD in a new page, and we implemented the law of cosines in this triangle ODB. So actually, this is triangle ODB that I copied from the original drawing. We know that OA equals to OC equals to OD equals to OB. They are there of this circle that equals to R. Therefore, all those 4 line segments are defined as the radius of this circle that is R. So repeat again, OB equals to OC equals to R, and side BD equals to 2 units in its length according to what is given as the equation. Now we will implement the law of cosines in this triangle BOD. According to the law of cosines in this triangle BOD, cosine x equals to BO squared. BO is R, therefore BO squared is R squared, plus OD squared. OD is R, therefore OD squared is R squared, minus BD squared. BD is 2, therefore BD squared is 2 squared, that is 4. So in total, in the numerator of this expression, we have r squared plus r squared minus 4. And we have to divide it by 2 times OB times OD. So it is 2 times OB is r, and OD is r. So it is 2 times r times r. So in conclusion, according to the law of cosines, in this triangle BOD, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. R squared plus r squared is 2r squared, so in total in the numerator of this expression we have 2r squared minus 4 divided by 2 times r times r. 2 times r times r is 2r squared. So here we have 2r squared over 2r squared is 1, and we have also minus 4 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. 2r squared over 2 is r squared. So in conclusion, we should find out that according to equation 1, cosine x equals to 1 minus 2 over r squared. Okay. In the next step, I copied this triangle AOC in a new page and implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. Again, we already found out that CO equals to AO, they're both the area of the circle, that is equals to R, according to our definition. It is given as the equation that AC equals to the square root of 2, and this is angle Y. So according to the law of cosines, in this triangle AOC, cosine Y will be equal to CO squared. CO is R, therefore CO squared is R squared, plus OA squared. OA is R, therefore OA squared is R squared, minus CA squared. CA is square root of 2, therefore CA squared is square root of 2 squared, that is 2. Divided by 2 times OC, that is R, times OA, that is R. So in total, in the denominator we have 2 times R times R. So according to the law of cosines, in this triangle AOC, cosine Y equals to R squared plus R squared minus 2 over 2 times R times R. R squared plus R squared is 2R squared. So in total, in the numerator we have 2R squared minus 2 divided by 2 times R times R, that is 2R squared. Here 2r squared over 2r squared is 1, and we have also minus 2 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in conclusion, I should find out that cosine y equals to 1 minus 1 over r squared. Okay, again, I should find out that according to equation 2, cosine y equals to 1 minus 1 over r squared. This is according to equation 2. But we actually found out that y equals to 90 degrees minus 6. Y equals to 90 degrees minus 6. Now we can substitute y in this equation, equation 2, by 90 degrees minus 6. We did it and found out actually that cosine y, and y is 90 degrees minus 6, is equals to 1 minus 1 over r squared. So according to equation 2, we actually found out that cosine 90 degrees minus 6 equals to 1 minus 1 over r squared. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus 6. So according to this trigonometric identity, we can substitute cosine 90 degrees minus 6 by sinus x. We did it, and we found out actually that according to equation 2, cosine 90 degrees minus 6 is sinus x, and sinus x equals to 1 minus 1 over r squared. This is according to equation 2. Again, according to equation 2, sinus x equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have the value of sinus x in terms of r, and we have also the value of cosine x in terms of r. And r is the radius that we are looking for in this question. R is the radius of this circle, that is the radius that we are looking for in this question. Now we used the trigonometric identity that states that sinus square x plus cosine square x is sinus square x plus cosine square x equals to 1. So we can substitute sinus x in this equation by 1 minus 1 over r squared, and we can also substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. We did it, and we actually found out that we have sinus square x. Sinus x equals to 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared squared. We have plus cosine square x. Cosine x according to equation 1 equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared squared. And it equals to 1. Okay, those two, the trigonometric identity, it is actually identical to this equation 3, because we just substitute sinus x by 1 minus 1 over r squared, and substitute cosine x by 1 minus 2 over r squared. So those two expressions are actually identical. So according to equation 3, we actually found out that 1 minus 1 over r squared squared plus 1 minus 2 over r squared equals to 1. Here we multiply this expression by 1. So this expression equals to 2 times 1 over r squared. In the next step, we defined t as 1 over r squared. Again, t equals to 1 over r squared according to our definition. And then we substitute 1 over r squared in this equation 3 by t. Repeat again, actually define t as 1 over r squared. And then we substitute 1 over r squared by t in this equation, equation 3. So according to equation 3, we have here 1 minus 1 over r squared. We substitute 1 over r squared by t. So this expression in total will be equal to 1 minus t squared. Here we have 1 minus t squared. And we have also 1 minus 2 times 1 over r squared. So it is 1 and minus 2 and 1 over r squared is t. So in total, this expression will be equal to 1 minus 2t squared. Again, this expression in total will be equal to 1 minus 2t squared. Here we have 1 minus 2t squared, and it is equals to 1. So it is equals to 1. So actually, according to equation 3, we actually found out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets on this side of this equation, equation 3, and we actually found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2 times t, and we have also 1 minus t minus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 1 times 2t is minus 4t equals to 1. Here we have 1 on both sides of this equation 3, so 1 will get cancelled. After we cancelled 1, in this side of equation 3 we left with t squared plus 4t squared is 5t squared, and we have minus 2t minus 4t is minus 6t, plus 1 equals to 0. So actually found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t. the coefficient A equals to 5, the coefficient B equals to minus 6, and the coefficient C equals to 1. The only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x, and we find out the value of the values of t, because x equals to t. So we did it, and here we substitute x by t. We found out actually that t equals to minus b. B is 6, so minus b is minus 6, that is plus 6, plus minus square root of 6 squared, square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36, minus 2 times a. Minus 4 times a. A is 5, so minus 4 times 5 is minus 20, times c. C is 1, so minus 20 times 1 is minus 20. So in total, inside the root, we have 36 minus 20 divided by 2a. A is 5, so 2 times 5 is 10. So we should found out that t equals to 6 plus minus 36 minus 20 is 16. So inside the root, we left only with 16 divided by 10. So we should found out that t equals to 6 plus minus the square root of 16 is 4 divided by 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1. From one side t equals to 1, but from the other side, according to our definition, t equals to 1 over r squared. Now we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1. We multiplied this equation by r squared, and finally found out that r squared equals to 1. Here we took a root out of this equation, and finally found out that r, the radius that we are looking for, is equals to the square root of 1, that is 1. So according to the first solution for t, the radius r of this circle is equals to 1. But it is impossible that the radius of this circle r will be equal to 1. Why? Because of the fact that this is line segment BD is equals to 2 units in its length, or chord BD equals to 2 units in its length. You know that chord BD is equals to 2 units in its length, and chord BD is definitely not the diameter of this circle. Again, chord BD or chord DB is not the diameter of this circle. So here, chord BD is not the diameter of the circle. And you also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And the diameter of this circle is 2r. So 2r is the longest chord in the circle. So the diameter of this circle that is 2r must be greater than BD, that is not the diameter. Again, the diameter 2r of this circle, that is the longest chord in the circle, must be greater than DB, that is not the diameter. But DB equals to 2. And from this equation, 2r is greater than DB equals to 2. We derive that 2r is greater than 2. 2r is greater than 2. We divided this inequality by 2, and finally found out that radius r of the circle that we are looking for is greater than 1. So the radius of this circle must be greater than 1. If the radius of the circle must be greater than 1, the radius cannot be equal to 1. So the first solution is the correct solution, so we cancel the first solution, and we will take into account only the second solution for t. And the second solution for t is that t equals to 6 minus 4 over 10. Okay, repeat again. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t, t equals to 1/5. from one side, but from the other side, according to our definition, t equals to 1 over r squared. So we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1/5. And 1 over r squared equals to 1/5. Of course, multiply this equation and finally found out that r squared equals to 5. Again, r squared equals to 5. We took out of this equation and finally found out that the radius r of this circle, that is the radius that we're looking for, is equals to the square root of 5. The radius r of this circle is equals to either the square root of 5 units in its length, or in terms of numbers, the radius r of this circle is equals to 2.236 units. Okay? Thank you very much.